Hi everyone, this is Shadaj again, and today we'll be solving problem number 6. Here we have the problem. The sum of the squares of the first 10 natural numbers is 1 squared plus 2 squared all the way up to 10 squared, which equals to 385. The square of the sum of the first 10 natural numbers is 1 plus 2 all the way up to 10 squared, which equals to 55 squared, which equals to 3025. Hence, the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 3025 minus 385, which equals to 2640. Find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. So we know by looking at this problem that the main thing we're going to be doing is figuring out how to calculate the sum of the squares and the square of the sums. So let's get started. Here I'm in Eclipse, and let's start by figuring out how to calculate the sum of the squares. So basically we want to keep on adding together those squares of the numbers from 1 to 100. So what I'm going to do is I'm going to have val sum squares, and we'll start by creating our range from which is the first 100 natural numbers, 1 to 100. And then what I'm going to do is I'm going to find the square of all of these numbers. So to do that I can do .map, and then what I'm going to return is I'm going to take my number and I'm going to return our number times itself. And we can remember that in this case we can't use the underscore trick, because to use underscore you have to have only one parameter, which we do have, but you need to use it only once, whereas here we're using it twice. And now we have all the squares of the numbers, so all we need to do is find the sum using .sum. So now we found the sum of the squares. Now let's find the square of the sum. So val square sum. And to find the square of the sum, we're first going to calculate the sum of all of these numbers. So I'm going to have val sum. And what it's going to be equal to is our first 100 natural numbers, 1 to 100. And we can just do .sum. And now we can do val square sum, and what that's going to be equal to is the sum times itself. And the reason why we calculated the sum separately is if we had done square sum equals to 1 to 100 dot sum times 1 to 100 dot sum, we would be calculating the sum twice, whereas just by doing this one val we only do it once. So now we know the sum and the squares. We know sum of the squares and square of the sums. And if we look at the problem, we need to find the difference between sum of the squares and square of the sum. So you can print ln, or let's first create our val answer, and that's going to be equal to the sum of the squares minus the square of the sum. Now we can print on our answer, and we can run. Okay, so we got our answer, but it's a negative number. So they want us to find the difference between this, which is the square of the sum. So the way they did it is they when they solved the problem from the numbers from 1 to 10, they did the 3025, which is the square of the sum, and then they subtracted the sum of the squares from that, because the sum of the squares in this case, in our case, is going to be less than the square of the sum, and also for the case in 1 to 10. So basically what we need to do is we need to swap. So instead of doing sum of squares minus square of sum, we can do square of sum and sum of squares. Another way to do this would be to use the absolute value, but we know that in this case our sum of squares is always going to be less than square of the sums, so you can just do square of the sum minus sum of the squares. So square of the sum minus sum of the squares. So now we can print one, and you get our answer. So now we can look at, there's a better way to do the sum of the squares. If we look at it, all we're actually doing is accumulating an overall sum of all the squares of these numbers. Wait a minute, accumulate? That's the keyword for using folding. We saw in Euler 5 how we used folding to calculate an overall LCM. So we can use a similar thing to calculate this overall sum of the squares of these numbers. So now what I'm going to do is I'm going to take out this, and I'm going to do dot fold left. And we know that in fold left we start off with a starting accumulated value. So I'm going to give 0. And then what I'm going to do is I have my two parameters, which is a and b. And then what I'm going to return is, and A is the accumulated value, B is the current value. So I'm going to return A plus B times B. And I'm going to put B times B in parentheses. Okay. And now we can run. Run as. So now we get our answer. And this was a faster way to do it, because before what we were doing is we were going over the whole list, whole range to map all the numbers to their squares, and then going over the whole thing again to calculate the sum. Whereas with fold left, we're only going over it once, and we're accumulating an overall sum of the squares.